Find the limit. The limit of x cubed e to the negative x squared as x approaches infinity. If we try to do the product rule here, of course, x is getting closer to infinity. That means it's getting larger and larger. If you take a very large number and cube it, you get infinity. Now, the e to the negative x squared, the negative exponent actually drops this into the denominator. So this would be e to the x squared in the denominator. As x gets larger, x squared is going to get larger. And as x squared gets larger, e to the x squared gets larger. So in fact, we're also dividing by infinity. Now this is another indeterminate form. And it is one that L'Hopital's rule would apply to. So we apply L'Hopital's rule. L'Hopital's rule says you take the derivative of the numerator divided by the derivative of the denominator and then take the limit of that. So the limit as x goes to infinity. The derivative of x cubed is 2x squared. Sorry, 3x squared. Divided by the derivative of e to the x squared is e to the x squared times the derivative of x squared, the chain rule there. The derivative of x squared is 2x. So now we would have a situation where we may cancel a factor of x from the numerator and denominator. And if we try to take the limit of 3x as x goes to infinity, that's going to go to infinity because x is getting larger and larger. If you multiply it by 3, it gets larger still. And 2 times e to the x squared, if x gets larger, x squared gets larger, and e to the x squared also gets larger. Multiplying by 2 makes it worse even. So we still have infinity divided by infinity. So we can apply L'Hopital's rule one more time and hopefully get what we need. So L'Hopital's rule says you take the limit of the derivative of the numerator divided by the derivative of the denominator. The derivative of 3 times x is just 3. The derivative of 2 times e to the x squared, the 2 comes out, it's a constant. The derivative of e to the x squared we did before. It's e to the x squared times 2x, the chain rule. Now when you do the limit, 3 is a constant. So the limit as x approaches infinity doesn't change it. It's 3. However, the limit of the denominator, as x gets larger, then x squared is going to get larger. E to the x squared is going to get very large. And then x is large. We multiply all that together, you end up with a large number again. So the numerator is getting closer to 3. The denominator is growing without bound. It's getting larger and larger, so the whole fraction gets closer to 0. So the limit of the original function is equal to 0.